You know, earlier Cisco had one protocol, and that was called as IGRP, Interior Gateway Routing Protocol. But the problem with this is it's a classful protocol. Classful, like RIP version 1, this is also Cisco's version 1 protocol, routing protocol, which is IGRP. It was classful. As a result, we were not able to use this protocol in a big environment where there are a lot of subnetted networks. So Cisco came up with another version by enhancing it as a classless. So they named it as EIGRP, enhanced Interior Gateway Routing Protocol. How nicely they have named this interior. Yes, this is not a protocol that's supposed to run on the WAN. OSPF is an internet protocol. BGP is the internet protocol. ISIS is internet protocol. But RIP and EIGRP are only meant to be within an autonomous system. That is IGP protocol, Interior Gateway Protocol. RIP, IGRP, EIGRP, even ISIS, OSPF. All these are IGP protocol, but this can be seen in the big level in the internet sometime because they are well structured. OSPF and ISIs or the architectures are very nice so that they can support any large network, but prefer to be used only within the autonomous system, within ISPs. You will see ISIs and OSPF within within the ISP. This one is seen within the enterprises. Even enterprises do use ISIs and OSPF, but not all. Not all enterprises uses OSPF and ISIS. You might have seen some using EIGRP, some using RIP. ISIS mostly we'll see in ISP environment. ISIS is in ISP environment, but there are some people who knows the importance of ISIS, willing to use ISIS even in the enterprises. So you cannot say this is for ISIS only or this is for enterprises only. You will see all this protocol in any size network.
Right.
Yeah, so there's nothing like this is more important, that is not important. Everything is important. Every protocol is important. Now, one of the IGP protocol is EIGRP, Interior Gateway Routing Protocol. Enhancement, what enhancement is done? This is one of the enhancement. There are many more. One of the enhancement is classless. Classless is one of the enhancements. EIGRP is a classless routing protocol. Because it is classless, we can say it supports variable length subnet mask. VLSM. You know what is VLSM, right?
Yes, when you use subnets, if you have a class, say a 10 network and you put a 24 prefix length on it.
No. That is subnetting. VLSM is within your organization. You have some part of network with /24 subnet, some part of network with 16 subnet, some part of network with /30 subnet. So you got
Okay.
variable length, not same length
Okay.
everywhere. Some part you have /23, some part you have /22, you know, that is variable length. Now, only when a classless protocol is very effective, very sharp and accurate, you can have such a variable length subnet mask. EIGRP is very sharp in calculating the prefix length. See, you remember when we configured RIP, the subnet mask was copied from the interface configuration. It was not configured by us. Subnet mask. It didn't allow us to configure subnet mask or wildcard mask, isn't it?
Right, that's correct.
In RIP, you don't have an option to specify the subnet mask or wildcard mask. So it always copied the mask from the interface configuration that you put. On the interface, if you put /16, it will say 16. In the interface, if you say /24, it will say 24. But in EIGRP, you have control over what to be advertised. By specifying wildcard mask, you can say that. So EIGRP has got more visibility to the subnet mask. So EIGRP can support variable lengths of subnet mask for the same network. VLSM, you understood VLSM, right? Variable length subnet mask.
Yes, no.
Different subnet mask in the same topology. Still, you will not have any problem in convergence because this is an effective classless routing protocol. Next, because it's a classless routing protocol, it can support discontiguous network. What is discontiguous network? You see, I have I'm just drawing 3 routers. It may be many more. Now I have here 172.16.0.0/24, and here I got, for some reason I just switched to 192.168.0.0/30, and here I got 192.168.0.4/30, and here I got 172.16.1.0/24. Now, if you don't have a classless routing protocol, you will not see these networks pinging. You will not see A pinging B or B pinging, sorry, C. There won't be any convergence. This is called discontiguous network. You see, so 172 is here as well as here. It is not contiguous, it is discontiguous. You have 192 here and you have 192 here. You can discontiguous can also be seen continuous, but they don't use the word continuous. They say contiguous, discontiguous network. So you got a network scattered here and there, scattered here and there. 172 is scattered here and there. So only when you have a very good classless routing protocol, these networks can get converged. These networks advertisement can reach the other router. R1 will learn about B and C only if it is a classless routing protocol. Otherwise, you know what we'll do? When R2 advertises the C network, if it is class full protocol, R1 will say, I already have 192, I'm not going to take yours.
Yes, yes.
Yep. So this continuous network is supported in EIGRP because it's a classless. It's a classless routing protocol. Next, EIGRP is designed to support various network layer protocol. And you got separate protocol for each network layer protocol, meaning you got separate module, you got separate separate algorithm. Can you say what is the network layer? Layer 3, OSI. Yeah?
Right.
Now,
Yes, yes.
in layer 3, which we call as network layer, we have IP. We also have
Right.
IPX. We also have what? IPX. We also have AppleTalk. But though we are not using it, it is still there. It exists.
So,
These are all
right,
equivalent to
right.
IP. We are in the IP world today. But earlier in the like 30 years back, some were having IPX, some were having IP AppleTalk. Yes, it was true. I heard those things. So the winner is IP at last. IPX and the AppleTalk. People did not pick it up. It didn't get famous. So IP has become popular. But in EIGRP they designed a separate algorithm to support IP, to support IPv6 a separate algorithm, to support IPX separate algorithm, to support AppleTalk separate algorithm. What I'm saying is, if you run one EIGRP, you cannot run all of them. You got independent module for each. Did you understand? You got a separate module to support IP, EIGRP for IP version, EIGRP for AppleTalk version, EIGRP for.
But the thing is this. How do I know which one I am running? So for instance, I go on a router and I type and I enable EIGRP. How do I know I'm enable it for regular EIGRP, EIGRP IPv6,
Okay, the
IPX?
commands vary. The command to enable EIGRP for IP and IPv6 is not the same. Same way, you also have different command for IPX. But anyway, these are all not supported right now in routers. But there is
Okay,
EIGRP protocol for IPX. Now, I just want to talk on
okay.
this thing for your question to answer. I want to take this as an example.
Mhm.
When I want to run EIGRP for IP, my command will be router EIGRP autonomous system number. But when I want to run for
Right.
IPv6, the command starts with the IPv6. IPv6 router EIGRP 10. The command starts with IPv6, which means it is using IPv6 version of EIGRP. Now there is a newer version EIGRP in which you can have both of them. For
Right.
that, we use a named convention, not this autonomous system. Let us not get into those things now. It's too early. We'll see those things later. Those things comes under advanced EIGRP. When we go there, we'll see that. Now, what I
Okay.
want to say here is this is not like other protocols. If you take OSPF, you don't have support for IPX and AppleTalk. Only for IP you got IP and IPv6. You may say like, who cares? We don't use IPX and AppleTalk. That's true, but Cisco wants to say that hey, we also got support for IPX, AppleTalk.
Right.
Of course, that's something unique which Cisco has got. Right. Now, these are the layer 3 protocol that EIGRP has got independent module. Now, EIGRP has got something very unique, which is unequal cost load balancing. BALNCIH. My pen is not that good, okay? So my handwriting.
That's fine. That's fine.
I need to change that. Balancing. Unequal cost load balancing. What does that mean? See, in a RIP, we learned that when you got multiple paths with same hop count to reach from A to B, B destination can be reached via 1 as well as 2 as well as 3 because the same number of hop count, isn't it? 2 hops. We call this as equal cost load balancing, which is supported on every routing protocol except BGP. So routing table on this router to reach B, you will see 3 routes, one via 1, 2 and 3. You will see all 3 routes in the routing table. So to reach B destination, you can send the packet via this way, this way, this way. This is equal cost load balancing. Up to 4 is the maximum by default. Sorry, not maximum, by default, 4 paths. You can increase up to 32 or 16, depending on the version of the operating system. Now, what is not supported in OSPF and in RIP ISIS is unequal cost. Unequal cost is not supported. For example, if you don't have this router, a RIP will use only this path, isn't it? Only one hop.
Yes.
The other 2 paths cannot be used by RIP, but EIGRP can use it. RIP can use only this path. OSPF can use only this path, the path with the low metric. But EIGRP can use unequal cost path. You may have metric EIGRP, metric one path says 10, the other path says 12. You can use both. But by default, only a equal cost. Equal cost multipathing. By default, it is only equal cost multipathing it supports. Up to how many? 4.
4.
But you can tune EIGRP to make them support unequal cost load balancing. We learn these things. Next. In EIGRP, you got summarization, both auto summarization as well as manual summarization. You know what is auto summarization, right? In RIP also we did no auto summary. Globally, we summarize. Globally we disable. That is auto summarization. We configure that under router mode, isn't it? Where did we say no auto summary? Under router RIP or router EIGRP. Yeah. Now, what is manual summarization? Interface level summarization. That is called manual summarization. Manual summarization is a summarization that we do only for one interface, not for the entire router. When you do summarization, auto summarization, it is for entire router. To all the neighbors, it will send summary route. Whereas manual summarization is interface level. Only those neighbors that are connected via that interface will get the summary. All other neighbors will get detailed route. We'll see those things when we go there. But I'm just going to tell you
Okay.
here that we are not simply having auto summarization. We are also having something called manual summarization, a special thing which is not
Okay.
there in any other routing protocol. Now I'm just explaining that first word I said, enhanced. These are the enhancement that we have in EIGRP. Not only this, there are more enhancements like to calculate the metric in IGRP, there was only 24-bit IGRP protocol used 24 bits to calculate the metric, whereas EIGRP uses 32 bits to calculate the metric. More the
Okay.
number of bits, more granular you can go, isn't it? Right?
Mhm.
So
Yes, sir.
with